All right, so we're going to start by talking about last class's homework. So have that out, please. For the first two circles, we gave you the template of how to fill in those equations of circles. It becomes important to remember if we talk about the center of your circle is, we call that HK, and we talk about your radius of your circle represents R. When we talk about x minus h squared plus y minus k squared is equal to r squared, we can see those connections to the Pythagorean theorem. We can see a squared plus b squared equals c squared, and when you look at these circles, that should totally make sense to you, because from the center of the circle, you can draw any radius to any point x, y, and then there's going to be a horizontal and a vertical component for how we get to there and how we figure out that distance of that radius. And what's cool is that right triangle can be drawn in any orientation. So if you think about this orientation here, we have a horizontal and a vertical component. So it doesn't matter where that right triangle is, that x and y movement represents how we go. Anytime we want to talk about that x distance, we're used to in our x formula talking about the difference between it, and that's always a subtraction problem. The distance is talking about the difference is what's between them, and so that always demands subtraction. Our formula is naturally negative, so x minus negative 4 gives me an x plus 4. So for our circle B here, this minus a negative 4 is what gave me x plus 4. This minus negative 3 is what gave me x plus 3. Now my radius here is 2. So when I talk about that radius squared, if you put a 4 in here, be careful because of this little 2 that's here as the square. So it should be 2 squared. And you'll notice in the next section how I go back and forth between writing the radius squared as an exponent or simplified, just because I want you to see it both ways. Any questions on circle B or circle F of how to write those equations? Okay, so for these next 6, we gave you the circles, and we have to be careful about looking at the scale of our graphs. So here I'm counting by 10s, and here I'm counting by 2s for those last 2. So you need to be very careful. So check your work with mine. And you can see whether I call it 10 squared or 100, whether I call it 6 squared or 36, 4 squared or 16, 4 or 2 squared. So check your work.
Do you have to have the parentheses over the x?
No, the parentheses here are not necessary. They're just for clarity. So if you just had x squared, you'd be fine. Any other questions? All right, so it's kind of good to give some thought questions and let you guys have some kind of extra processing of what we're talking about. If we have circles in the coordinate plane and they have the same exact center and they have congruent radii, then that is just, they're identical. Because if they have the same center and the same radius, that's going to be an identically overlapping circle. Any 2 circles that have the same radii are going to be congruent. You think about in a circle, I only have one thing of measure. I only have my radius as a distance. So if 2 circles have that same only singular measure the same, they're guaranteed to be congruent. So if I have 2 circles that have equal areas, if their areas are the same, your formula for your area is going to be pi r squared. Well, if they both have the same area, they must have the same radius because pi is a constant. So then are the circles congruent? Yes, they are. Mason, what was your question?
I was just wondering about the fifth circle, you put the radius as 10 squared. Oh, never mind, I see it now. Now you found it. Yeah.
Are we good?
Yeah.
Awesome. All right, if two circles that have circumferences that are the same, remember my circumference is equal to either pi d or 2 pi r. If their circumferences are equal in length, that must mean that their diameters or radii are the same. So are they congruent? Yes, they are. If I'm talking about circles having an area of 36 pi, there's an infinite number of circles that have that. I could draw them all day long. If I have a center of 4, 7, how many circles have that center? As many circles as you want to draw. A circle with a 1-inch radius, 2, 3, 4, 5, 6, 7, 8, 9. Like I could expand the circles out forever and they would all have the same center. But when I'm talking about how many unique, and if you need that word unique or the word distinct, they kind of mean the same thing. If you're asking me how many unique circles have that same center and that same area, that's a big fat 1. Just one circle. Questions on that? Okay. So when we're looking at the top of this page, if I'm given my formula for my circle, from this formula, I can get my center and my radius. So remember, naturally negative. So this is a positive 5 as an x movement, and this is a negative 4 as a y movement. And my radius squared is 49, so my radius is 7. I had a kid one time say to me, I just think about what number goes in here that's going to zero it out, and then I know that's my center. So 5 goes in here, negative 4 goes in here, that zeroes it out. Some kids talk about, oh, I just remembered that that's what gets it back to 0. So if my x movement's 5, taking it back, negative 5, gets it back to 0. However it helps you remember it, rock on. From this formula, I get my radius, so I can do my circumference, and I can do my area. Lots of kids struggling with the idea about my circumference or area in terms of pi. All I'm asking for when we talk about it in terms of pi is before I go ahead and introduce an estimate for that pi value. So 14 pi is exact. 14 pi, I haven't rounded, I haven't compromised the true integrity. That's actual distance around that circle is 14 pi. That is precise. That's exact. When I enter pi into the calculator, and I'm going to use the pi button, not 3.14 because the pi button is even more exact, then I'm going to go ahead and get 43.98, and that's me rounding. If you're talking about area, I'm asking you how many little squares can fit in that circle, so your units are squares. If I'm talking about circumference, I'm talking about linear length, so your units are just regular old units. For this next one, when we talk about writing an equation of the circle with that diameter, the center of your circle is the midpoint. So if this is my diameter, my midpoint is going to be this, midpoint of my diameter is the center. So that's an extra layer of understanding what it is we're talking about, knowing to take the midpoint, finding the center. Now you have two choices. You can find the distance of the center to either this point or this point. Both will work out fine. Or you can take the distance of the diameter, divide by 2, and that'll give you your radius. So no matter which way you do it, if you're figuring out the distance from your center to A or your center to B, that's going to be your radius value. If instead you find the distance of AB, and then you just divide by 2 to get your radius. When it comes to writing the equation, I'm going to put my center points, x minus negative 3, y minus positive 4. Each of those are squared. And here's my radius squared. Please make sure you remember the difference between your diameter, which is the radius doubled, versus your equation where it has your radius squared. Not the same thing at all. For this one, I found my midpoint. There's my center, my distance and my diameter, my formula. Questions on 6? So 7 was kind of cool. Graphed each set of equations. That first was a circle. A and B are centered on the origin because there's no left or right movement for the x and y. C circle went to the left 2 and down 2 or up 2. So left 2, up 2. A radius of 8, a radius of 3, and a radius of 4. When I go ahead and I graph my linear equation, I start with my y-intercept, which is -3, and I count my slope. My coefficient to my x is my slope. Rise 1, run 1, rise 1, run 1, rise 1, run 1. And I can see what I have here is a secant line because it intersects my circle twice. When I graph this circle here with a radius of 3 and this horizontal line, this is a horizontal line with a slope of 0 because there's just a y in the equation. We call that a HOI. They share this one point, which makes this a tangent line to that circle.
This is for TA next week.
Okay, thank you.
Thank you.
Now this next one's kind of cool. When I went ahead and I graphed this my circle, I went to my y-intercept of 6 and I graphed the slope of down 1, -1. I was curious about this point here. Because when I draw my circles, they always end up getting flat or looking like an egg on one side. So I couldn't tell if that intersected or not. Because if it intersected once, it was a tangent, right? If it went through it, it would have been a secant. So what I did down here was I did a test. If 1, 5 was an intersection point between the circle and the line, when I plugged it into the circle formula, it would have made it true. It didn't. And because my distance with my 1, 5 was greater than, I knew that it existed outside the circle, so I knew it couldn't be a secant. Kind of cool. All right, last up. So this is the honors part of a lot of what we're talking about. We have to write the equation on the line tangent to the circle at that point. So I took that equation and I decided here was my center and here was my radius. Got it. What I really only needed was the slope of my radius. I went ahead and wrote the equation of it. That was a little too much work. I didn't need to do that. Once I had my slope, because I know that the tangent line is perpendicular to the slope at that point, I knew that the slope of my tangent line was going to be the opposite reciprocal. So -3/4, opposite's going to be positive, reciprocal is 4/3. So then I used point slope form, and I went ahead and I figured out my line tangent. Now, in years past, that's an honors geometry topic. That's something you're responsible for. That's without talking about a pandemic and kids missing out on half of algebra and not remembering the half that they were there for. So you're not necessarily being held accountable to that level. But what you need to understand is that's an honors question. And it's an honors question because look at what you need to know. You need to know the equation of the circle. You need to know how to find the center, what the radius is. You need to understand about intersections. You need to understand about finding slope. You need to understand that the radius and the tangent are perpendicular. You need to remember the slope of a perpendicular line and then how to write that equation. So as I walk around and I see the number of blank papers on the back, people that didn't even bother to do or try or draw, I'm wondering if you didn't get number 8, I get it, but there's really no excuse for not being able to draw these circles. So if the back of your paper doesn't have these on it, you need to do more geometry. You need to do more math. You need to lean in to the content that's being taught to you and do your part to practice it and learn it. Because this is basic, and this is on the SOL, and this is on your final. So for all the blank papers that I'm looking at out there, it's not enough from you. All right, so what I'd like you to do is I'd like you to talk to your group mates, and I'd like you to look at the back of these problems and the number of different ways that we asked you questions to work with, the content about equations of circles, and I'd like you to talk about which problem do you find the most interesting. Go. All right, so if you take a look at your note sheet, we're going to talk about 2 kinds of area that we find for these 3-dimensional figures. First of all, by definition, area is the 2-dimensional space that a shape occupies, and it's measured in square units. So the conversation says, okay, if I have a 2D space, what happens when I get a 3-dimensional figure? And we're going to have 2 different kinds of area measurements. One is your lateral area, and that's just going to be the sum of the measures of the sides. So when we go ahead and we look at the sides, one of my sons was a lacrosse player, and they had lat pads. And lacrosse players, because so much hitting and happens with the stick, he would have these special pads that he would wear to protect his lats, his lateral muscles. Any lacrosse players in the room that wear your lat? Do you wear the lat pads or no? He stopped wearing them because he didn't need them. He was a long stick defenseman, and he did most of the hitting and not most of the receiving. So he found that they just slowed him down. So he stopped wearing them, fine, and gave them to a lot of the middies or the forwards that ended up getting whacked by the long poles. But your lats are your side muscles. Think of that when you think about your lateral area. That's just the measure of the sides. When we talk about the surface area, that's going to be the sum of all the areas of the sides and then the base. And we're always measuring any 2D shapes in square units. Anytime we're talking about, we're asking ourselves how many square units fit inside of a shape. So again, when we talk about our prisms and cylinders, we can see the similarities there. When we talk about our pyramids and our cones, we can see the similarities there. And then, of course, our spheres we're going to come back to next lesson. When you talk about prisms, again, the prisms are named by the shape that's on the bottom. So triangular, square, pentagonal, hexagonal, octagonal, you can see that. A rectangular prism, we would have to be told which is the base, since they're all rectangles. Features that matter: rectangular sides or faces, 2 congruent polygon bases. Those bases are parallel, and the pyramid and the prism is named by the base shape. When we have a pyramid, again, it's named by that polygon base, but instead of having 2 bases, all those faces meet at the apex, and our faces are triangles. 1 base, and it's named by that polygon base. So you can see the similarities between prisms and cylinders, where we have two congruent parallel bases. You can see the similarities between prisms and cones, where we have the apex and just one base. With cylinders and cones, that base is circular. And with cones, that one side is going to be that sector of a circle. And you think about how if you open up a cone, it's going to be that sector of our circle, surface area wise. So on your pink sheet that is part of your SOL review packet, you have all the formulas that when it comes to finding our lateral and surface areas, to me, just breaking it up and finding the area of all the pieces and then adding them together makes more sense to me. So when I'm finding my lateral area, when I talk about my sides of this, my sides are going to be my rectangular sides. So if I look here at my pink, if I look here at my orange, and if I look here at my green sides, I can see that I have 3 rectangular sides. And those rectangular sides all have a measurement of 6 by 8. So when I go to find their area, 3 sets of 6 by 8 is going to give me 3 times 48, or 144 square inches. So that's what my lateral area is going to be. When I go to find my surface area is going to equal to my lateral area plus my 2 bases. For this example, my 2 bases are triangles because it's a triangular prism. So that's going to be 2 times 1/2 times my base times my height. If I were to look at each of these triangles, I know that they are 6 by 6 by 6 inches. If I were to figure out the area of this triangle, I could find the height. And when I do that, I take this equilateral triangle and I recognize, oh, it's one of my special right triangles. So if my side length is 6, my short leg is 3, and my height is going to be 3 times the square root of 3. So the area of my bases, I have 2 of them, is 1/2 times the base of my triangle, 6 times my height, which is 3 roots of 3. Here's my height, which is 3 roots of 3. So when I go ahead and I do that math, 2 times 1/2 is 1. 6 times 3 is 18. So 18 roots of 3. And I can go ahead and get my calculator. 18 times the square root of 3. 31.18 square inches for my bases. So my surface area is going to be the sum of these together. My surface area is equal to that plus 144. Oops. So my surface area is 175.18 square inches. So my surface area is going to be the total of my lateral area plus the area of my bases. Sound okay? All right, let's do the same thing for our cylinder. When we look at our cylinder, our lateral area is going to be, again, think about that Quaker Oats. Who has the Quaker Oats? Go ahead, open it up. It's that big rectangle. And if we look how that works here, that height here is my 5 meters, because here's my height of my cylinder there. But this distance here around the top is actually my circumference of my base, which I know is 2 times pi times r. So my lateral area is going to be 5 times 2 times pi times my radius. So I wind up with 40 pi square meters as my lateral area. When I want to find my surface area, I know that's my lateral area plus my 2 bases. My bases are circles. Here they are. Here's one here, and here's one here. And I have a radius of 4, so I know my bases are 2 times pi times r, which is 4 squared. So that sounds like 32 pi square meters. So when I want to find my surface area, I'm just going to add these together. So I can say that my surface area is equal to 72 pi square meters, or, and somebody might say, I don't want it in terms of pi. Can you give it to me in a rounded estimated decimal so I know closer to what it is? Sure, no problem. 72 times pi is 226.19 square meters. So that's going to be my surface area. When we talk about our lateral and surface areas of the square pyramid, we only have one base. So this one base. And instead, our faces are triangles, and those triangular faces introduce a new term for us, which is this slant height. So what I need to do to find this area of this triangular base is to figure out what this height is here. And once I figure out what this height is here, then I can figure out what the area of this face is. And we need to be careful because that's not the height here. The height here is the height of the actual prism, pyramid. This is the actual height of the pyramid. And we can see this height reflected here in this 97 meters. But if you'll notice, I need to make a triangle. And when I make this right triangle, that is the right triangle that I can use to figure out what this slant height is. So if I were to use that triangle, I can see I have a height of 97 meters, and you can see this width of the triangle is 1/2 of this side length. And this slant height is what it is that I need. Would you and your friends please use Pythagoras and tell me what that value is? Go. All right, do we agree? So the height of that side, and we call it the slant height because we don't want people to get confused between the height of the shape and the height of the face. So when we go ahead and we find our lateral height or our lateral area, I have 1, 2, 3, 4 of these sides, 4 of these faces that came from each of these sides. So I have 4 of these triangular faces. And I know that my area of a triangle is equal to 1/2 times base times height. So that's going to be 4 of them times 1/2. My base is 90. And the height I just figured out of each of those faces is the slant height of the shape, but the height of each of those faces. When I multiply that together, my lateral area for the sum of those together is 19,247.38 meters squared. That's my lateral area. My surface area is going to be equal to my lateral area plus the area of the base. When you see a big B, this represents the area of the base. And for that one, this one's easy. The area of the base is equal to 90 squared because it's a square pyramid. So my surface area is equal to 19,247.38 plus 90 times 90 is 8,100. So my surface area of this shape is equal to 27,347, and I'm going to round to 3800ths. And remember, it's square meters. How many square meters can fit in that shape? So a couple of things I'm going to point out while you're catching up is I do take the time to make sure that my work is meticulous. I do make sure that I label what it is I'm figuring out while I'm figuring it out. Because if I make a mistake, I want to be able to go back and see where that calculation went wrong. Did I forget my 1/2 for the triangle? Did I use the height instead of the slant height? Did I forget to square the radius? There's going to be mistakes. Getting this many calculations, and what ends up happening, especially when you're taking a multiple choice test, is you end up with an answer that looks nothing like your 4 choices. Nod your heads if that's happened to you. And you're like, oh, I'm just going to guess at the one closest. Chances are that's the least likely to be your answer. Because if you're talking about the one that's closest, that's not going to accurately represent the most missed mistakes that people make. Forgetting to square the radius, forget to 1/2 the base, forget to include all of the faces. So chances are your answer is off by more than just a little bit, because any one of those things is going to have a bigger impact than just a couple numbers. So you want to make sure your work is set up so you could go back and carefully check it. Of all the formulas that I have in my brain that I remember, the one that I do not always remember, that I will need the formula sheet for sometimes, is that lateral area of a cone is pi RL. And pi RL, this is the radius of my base, and this L is my slant height of the cone. So when I'm finding the lateral area of my cone, a reminder, that is the area of this sector. So I do have a discovery activity where we take what we know about sectors of circles, and we take this radius and the relationship between the radius of the base, and we put it all through a complicated formula, and we come up with pi RL. That's the other activity that we're skipping in the interest of time. So you're just going to have to trust me, pi RL, and you do have that formula on your sheet if that doesn't stick in your brain. So when we go to find the lateral area of this cone, it's going to be equal to pi times the radius of my base times the slant height of my side. So I've got 15 pi square meters as the surface area of the side of my cone, that area of the sector. My surface area is equal to my lateral area plus the area of my base. So we'll go ahead, that's a circle, so that's going to be pi times my radius squared. So that's going to be 9 pi. If I want to find my surface area, that's what I have to add together, which is going to give me 24 pi square meters, or if I want to figure out what that is, rounded to the nearest hundredth, 75.40 square meters. Surface area, the area of all the surfaces added up. Your choices as a student are to plug into those formulas or to just use the math you already know by taking the area of all the sides and adding them up.
For what's it called? When you add the 15 pi and 9 pi together, how come it won't become 2 pi because you're adding like 2 pi's together?
Because the pi's, those coefficients tell me how many of you are. I've got 15 pi's and 9 pi's. Together, that's 24 pi's. That's like saying if I have 15 cupcakes and 9 cupcakes, 24 cupcakes. So those pi's just add together. Those coefficients tell me how many I have. Sound okay? Yeah? All right. When we talk about volume, we're talking about a three-dimensional shape, a space that a shape occupies. So the reason I was able to go around and fill all of your containers up with popcorn is because this volume, this three-dimensional shape, has capacity. It's holding on to your popcorn. When we talk about what we mean by capacity, we're talking about that area of the base times that height. And I know you're used to length times width times height, but I'd like you to start thinking of it as area base times the height, because that actually is a formula that is more applicable beyond just base times width times height. So an interesting conversation is called Cavalieri's principle. And Cavalieri was a mathematician who said if you have two solids that have the same height and the same cross section to every area, then they have the same volume. And I want you to think about if I had a stack of books stacked up and some of the books were off center or not quite exactly right, no matter what, that volume, that capacity is constant. When we talk about the volume of prisms, what I'd like you to think about is when we talk about the area of the base. So if I have this container and I go to figure out the area of the base, when I put my shapes in it, if I have 4 by 4, what is the area of this base going to be? Say it louder.
16.
Yeah, it's going to be 16. So I'm going to be able to fit 16 cubes inside this shape. So there's my 16. There's my 1, 2, 3, 4 times 1, 2, 3, 4. So the interesting thing is when we talk about volume now I'm talking about how many times could I repeat the stacking of that base in order to fill up my container. So notice I'm measuring in cubic units. So do you see how this base area can be repeated 1, 2, 3, 4, 5 times? So when I'm talking about volume, when I'm talking about capacity, if I want to know how many cubes I can fill up in this container, I don't need to have, what's 16 times 5, 80? I don't need to have 80 cubes. All I need to know is that this area of the base, 16, could be repeated each of these times. 1, 2, 3, 4, 5 times. So that area of the base can be stacked up 5 times. So if we're talking about what this looks like in our notes, you can think about this first orange layer I have is my area of my base, and then I can stack each one on top, getting higher and higher. If I have a cube with a side length of 6 centimeters, that means that I can have this area of 36 square inches stacked up 1, 2, 3, 4, 5, 6 more times. If I were talking about a cylinder, my area of the base, this pi r squared, where I'm talking about how many square units fit in there, and then I want to know how many times can I stack that. This times the height is what tells me how many times that base can be stacked up. So when we're talking about volume of prisms, area of the base times the height. Volume is equal to, we're going to assume that this is a right triangle here, where my base area is going to be 1/2 of my base times my height. And then the height of my figure, that base is repeated twice. So my volume or my capacity for this one would be 3 cubic feet. As we talked about with your cones and your cylinders, the relationship between your cone and your cylinder was 1 to 3. This cone is a third. This cone is a third of the capacity of that cylinder. So when we go to figure out the area of the base times the height, what we need to do is take that final calculation and divide it by 3, because that cone and that pyramid has 1/3 of the capacity of that related cylinder. So if my volume is equal to area of the base times the height, I'm going to take 1/3 of it. My volume is equal to 1/3 my area of the base times my height. So my volume here is 1/3. My area of the base is pi times 9.5 squared. And then my height is 16.8. For my pyramid, my volume is equal to 1/3. The area of the base is 8 squared. And my height I don't have yet, because this is the height. So that area of the base times the height, this is the height that I have. This 7 centimeters is my slant height. So I'm going to need to do some triangle math. Hello again to Pythagoras. Where this is what I'm looking for, this is what I have, and this is what I have. So h squared plus 4 squared is equal to 49. H squared is equal to, so 49 minus 16 is equal to the square root of 33 is my height. So this height value here is going to be the square root of 33. So go ahead and with your calculators do a little calculator math. And we'll see if we agree on what you get for those calculations while I pass out your next papers. So let's see how you did. The way I like to do this is I like to do pi times 9.5 squared times 16.8. I messed up. See how it's all up in the square? That's not what I want. Let's try it again. 9.5 squared, and I'll hit enter to get that in, times pi times 16.8 divide by 3. For that volume, did you get 1,587.76 cubic millimeters? I see some head nods, so we're good. You better be pressing the buttons, because on SOL day, no one's going to be there to give you the answers. All right, let's talk about this one. When I go to calculate this one, I'm going to do the square root of 33, arrow out, times 64. That's my area of the base, times my height, divide by 3. And I get my volume is equal to 122.55 centimeters cubed. How are we doing on that one? Yeah? Okay. It's super important that you verify your calculations with a friend to make sure that you guys are getting the same values. Now, what's interesting here is, if you'll notice, I'm fairly meticulous with my work. I go ahead and I write down what it is that I'm doing, what it is that I'm multiplying, and I don't take shortcuts, because if I make a mistake, I want to be able to go back and go through my work to find the right answer where I messed up.
Can you explain the volume of the prisms? That one kind of confused me a bit.
The volume of the prism, area of the base times the height. My area of the base, this is a triangle. So my area of the triangle is equal to 1/2 times my base times my height. I made this my right angle, so here's my base and here's my height. So it's 1/2 times 1, which is my base, and 3, which is my height. And then when I'm talking about my volume, I'm going to multiply that by this height here. So here's my area of my base, and then here is my height. How many times I'm going to be able to stack that going up. Sound okay?
Mm-hmm.
All right, so let's talk about the back for a little bit. Just some conversations that you should take some time to see. Surface area and volume properties. If two polyhedra, that's a fancy word for these three-dimensional shapes, are congruent, then they have the same surface area and volume. The area of a two-dimensional composite figure is the sum of the areas of its non-overlapping parts. So if you have something like this, where you don't have a formula for, you can find the area of all the different pieces. You can find the area of this triangle. You can find the area of this rectangle. And you can find the area of all of these non-overlapping parts, and you're good to go. Same is true of a 3D solid. What's interesting is we can talk about prisms, pyramids, cylinders, and cones in a term of a right, where it's straight up and down, or it's oblique. And that oblique means that it's tilted over, and you need to make sure you're using the right height calculation. Now, spheres are going to be something that I genuinely will go back and re-look at these formulas for. What's interesting about the surface area of a sphere, if any of you play baseball or tennis, and you look at a ball, you can kind of see, here I took this ball and I cut it apart. You can kind of see that that baseball or that tennis ball really is 4 little circles kind of stitched together. So if you can imagine that baseball, you can see how it's those 4 little circles kind of stitched together. So the surface area makes sense that it's 4 pi r squared. Because pi r squared is the area, and you have 4 of them, so that's kind of fun to look at. And then, of course, for our volume, give it another radius and divide by 3. That's going to be that volume of the sphere. You will have the formulas when it comes time for that. Would you please have one member of your group please return the shapes to the back? Would you please also check your floor for popcorn kernels and throw out the rest of your popcorn?
I said not in my head before you go.
Thank
Who said that?
Oh, wait.
Like, said it.
So lateral